Morning. I am the Chief Marketing Officer of Vapor.io, and I also wear a number of other hats. Probably most relevantly, I'm the co-chair of the State of the Edge, which is a membership organization that last year published a landmark report, the 2018 State of the Edge report. This is a vendor-neutral group that it looks to publish original research relative to the Edge, to advance the understanding of the Edge, to accelerate the deployment of Edge, and we try to do it in a very unbiased way. We are going to be soon publishing our 2019 report. We just published a single topic report called Data at the Edge. We have a report called 5G at the Edge that's coming out. All these are free of charge. They're all offered under a free license, an open source license, a Creative Commons license, and you can download them at stateoftheedge.com. So we began this journey 18 months ago. Jacob Smith, the Chief Marketing Officer of Packet, and I over beers, and we asked a very deceptively simple question, which is, where is the Edge? And I went back, because I couldn't answer it myself, and I asked everybody that I respected, and these are some of the answers I got. I got the Edge is the wall of my data center. That's where the Edge is. It's my factory floor. Base of a cell tower. This is my favorite. Somebody actually said, the Edge is the bumper of my car. The truth is, each of these is an edge to somebody. But what do you do with this? It's a mess. So we had an insight, and that is, while there are all of these edges, the edge we care about, the one we care about today, the one we mostly talk about in this room, is the edge of the last mile network. There's two sides to it. There's an infrastructure side and a device side, and there's going to be a lot of data center technology deployed in both. So why is this? What's causing this? So the first thing that's causing this is the cloud. The cloud has become a dominant part of the way that we deliver and consume services. It is, almost everything we do, unless we're working on an NSA computer that's air-gapped, depends to some extent on the cloud. And then we have billions of devices, not just cell phones. We have sensors, we have cameras, we have automobiles, all of these out there. And then we have this incredible Rube Goldberg machine called the internet that connects these two. So let me give you some specifics here. So this is Amazon's data center footprint, if you exclude the data centers that only the government can use. And these data centers run all of Amazon's web services. This is a map of the major internet pipelines in the United States. There's only 40 major on-ramps onto the internet for the entirety of everything we do in the US. It has to go onto the internet and more or less in 40 locations, which is tiny. And a lot of those locations are actually in the same city. And then we take all this compute, all this data, we push it through these pipes, and then when it gets to the end of the pipe, it has to do this. This is Verizon's coverage map. So you can quickly see, between the cloud that's centralized and the device that's everywhere, we have a system that wasn't built to serve for this. So the future is breaking the internet. So let me walk you through a very specific example. So if you pull out your cell phone and you refresh LinkedIn, Facebook, whatever, that signal first has to go to a cell tower. And in today's world, let's say that's 10 milliseconds. I think that's kind of generous with some networks, but let's say it's 10 milliseconds. And then from that cell tower, it often goes to a central office. That adds maybe 20 milliseconds. We're up to 30 milliseconds now. Then from a central office, probably passes through a carrier hotel or equivalent. We're now up to 50 milliseconds. And then eventually, through best effort, BGP routing, and all of that, if we're lucky, it gets to a centralized data center in 100 milliseconds, and our round-trip time is 200 milliseconds. So typically, from a centralized data center to an endpoint, from Seattle to New York, you're probably looking at 100 to 200 milliseconds of delay. That's 1 to 2 seconds. And that is not enough time to control a robotic arm. It's not enough time to provide decision support to an automobile that's traveling 60 miles an hour. It's not enough time to deliver real-time AR, VR to a headset. So what are these needs that are driving the edge? So the first one, and I get asked this question a lot, the first one is we're moving from an internet that operates at human scale to an internet that operates at computer scale. So humans operate in ones of seconds, right? You know, I press something on the screen, maybe a half a second or a second goes by, that's fine, I'm comfortable with it. A machine, that is an eternity, that is glacial. So there's this demand, the more machines that we're connecting to the internet, the higher the demand for this low latency connection. The second thing is we're not dealing with millions of devices anymore. We're dealing with billions, and not just ones of billions, tens of billions of devices. And to route all of that back to a centralized data center, there just simply isn't enough fiber in the ground. The other thing is data center workloads that traditionally were on-prem are migrating to the cloud, maybe not in their entirety, but certainly partially. And to the degree that the cloud becomes as responsive and in many cases more secure than my local data center, more of those workloads will move into a cloud environment. And finally, we're moving from static delivered web pages to real-time multi-dimensional experiences, which require huge amounts of data and very low latency. If you don't update a HoloLens headset fast enough, you're going to get sick. So these new needs, they require a new internet. And that new internet has to be a lot faster than the current internet. And as you recall, this Rube Goldberg machine, we don't really have a system for fixing it other than what we call edge computing. And in this example, edge computing is simply taking the compute that exists in centralized data centers, most often considered the cloud, and pushing those resources as close to the end device as possible, potentially in the parking lot of a building for a factory, but I believe increasingly at the access edge, so one hop from the wired or wireless last mile network. And that's what's going to help drive these new use cases, is that massive build out of data center capacity at the edge. So I also get asked, okay, autonomous vehicles, when are they going to come? Why is edge computing important today for autonomous vehicles? I've got, AR, VR, maybe today it's a kid's thing and I can run it off my Xbox or my Oculus. What is actually driving deployments? What is actually driving deployments in 2019? And if you think about it, the answer is actually kind of obvious. And that is these four. So this is infrastructure. 2019 is the year that we start at scale building the edge infrastructure that I just described. And the companies that are deploying that equipment tend to be in one of these four categories. They tend to be the telcos, which are virtualizing their networks and moving to 5G. And that simply means in the past they used to buy these dedicated appliances from Ericsson and Nokia and so on. And inside those appliances was proprietary software, proprietary signal processing, and an Intel PC. That Intel server is coming out of the appliance. It's moving into a traditional data center environment, traditional data center rack. The workloads that used to run on those appliances are being cloudified, run in a cloud environment. And all the benefits of moving that appliance level model into a software plus hardware model is supporting all the things that we tend to benefit from the cloud. And that is, scalable workloads that can migrate, resilience, centralized orchestration, all of these things, including a lot of cost savings. So that's one of the big drivers, is the telco operators deploying lots of white box servers into edge environments to upgrade their network. The next one is the CDNs. So CDNs were the first edge computing. I mean, Akamai was doing this, over a decade ago. They invented edge computing. In fact, the first reference I can find to edge computing is a research paper that came out of the Akamai folks, which originated from MIT. And so the CDNs know that they need to push their devices farther out into the network, both to reduce latency, but also to deliver some of the new services that the CDNs are moving into. CDN stands for Content Delivery Network. They're doing a lot more than delivering content. They're offering security services. And so again, the farther you're out in the perimeter, the easier it is to detect anomalies before it infects a larger part of the system and sequester an area. The more you subdivide your network and push it out, the more capacity, the more devices, the more people that you can serve. And then finally, the CDNs are starting to look a lot like cloud providers. Companies like Cloudflare and Akamai let you run these workers, and StackPath, another CDN, will let you run containers or VMs. So the CDNs are starting to look a lot like low-latency cloud providers. The cloud providers themselves, and not just the big ones, some of the innovative cloud providers like Packet, but virtually every cloud provider that wants to be competitive in this next generation is deploying equipment at the edge. And again, the reason they're doing that is because they're looking to enable these new class of applications, and they know that the developers on their platforms are going to want to utilize those services, and they're going to be able to increase the size of their business by providing cloud-based environments at the edge that those customers can purchase. Each of the cloud providers has a different strategy. Some are looking to build edge into their end-to-end IoT toolchain, kind of embedded in there. Others are looking to offer what you would typically find in their centralized data centers, but an edge version, which will probably be priced differently. So you could buy storage like S3 at the edge, or compute like EC2 at the edge. And then finally, the streaming game providers. The streaming game providers, which is the only end user application that I'm seeing deployed today, but it is a giant opportunity. I mean, makers of Fortnite are doing $1 billion a year in business. It is a major trend that will drive a lot of edge computing. So what does an edge data center look like? So this is actually a real example that my company, Vapor.io, is deploying. This is in Chicago, and that is an equipment shed that holds telephony equipment. That's a cell tower. This is serving more than that one cell tower. It's actually called an aggregation hub. There's hundreds of cell towers that are served by this with fiber runs. And inside the cell tower, oh, here's another example, sorry. That's a brewery on the left. This is another shed. And inside these, we have a micro data center technologies. This happens to be our version of it. It's called the Vapor Chamber. That round device, it's 9 feet in diameter, so maybe from here to the screen. And it provides 165 kilowatts of compute, so very, very, very dense edge location. And as Yuval was saying, one of the reasons that you want, I think I have one that's being constructed here. Yeah, one of the reasons that you want to have Open19 in these environments is so that you can make a standardized deployment in an Open19 configuration, full rack, half rack, and ship it. And a relatively unskilled technician, I mean somebody who's not skilled in data centers, can install and or swap. So you think about the people that service these environments already. They're climbing towers, they're working on telco equipment. What are they going to do with a cloud provider's box? Well, the solution is they've got Open19 configurations in the warehouse. The truck roll goes out. The technician, it's an hour of training and a 5-minute process to swap a device in and out. So, what are the takeaways? So these trends are real. There's massive amounts of compute that are being deployed in the edge. As I mentioned, 2019, it's mostly infrastructure-based compute, but once the infrastructure is out there, the developers will start utilizing it, and we'll start to see all these magical applications from autonomous driving to augmented reality. Big deployments are starting in 2019. My company, for example, is deploying in 6 cities, and each of those cities is going to have 3 to 4 data centers. And as I mentioned, Open19 is ideal for these deployments. We are encouraging every one of our tenants, we're a co-location interconnect company, every one of our tenants to standardize around Open19, which will reduce their cost of installing and swapping equipment. So lastly, I just want to point to some of the resources that I mentioned earlier in the talk. One of them is the State of the Edge report. Again, this is this vendor-neutral, collaborative. It has an editorial mission, not a sales mission. We started with 5 members. This year we're like 45. It's a relatively inexpensive membership to join. If you're a startup, 30 or fewer employees, it's $2,500 a year. If you're a larger company, it's $7,500. So it's the kind of thing that you can put on a credit card. And we put 100% of those funds into publishing this material and, again, putting Creative Commons license on it. 2 of the side effects from last year's report that I'm really proud of. One of them is the edge computing landscape. So we built this landscape, a taxonomy of all the different players in edge computing, at least our first tack at it, and we published it. I'm proud to say that it was recently adopted by the Linux Foundation as an open source project. So we transferred the IP of the original landscape into the Linux Foundation. It's now a highly dynamic, it's got a code base and a database, and you can slice it in many different ways. Very early stages in terms of populating it with the categories and the items that are in the taxonomy, but it's a rich open source project. Anybody can join. There are weekly calls, so if you have an appetite for participating in this, please consider doing that. And then the other one was this Open Glossary of Edge Computing, which I chair, and this came out of the report. It basically was, we had 6 authors working on the report. We needed a common style sheet. What is the definition of access edge? What is the definition of infrastructure edge? What is the definition of compute offloading? All these things. And we created what amounted to a glossary. And when we shared it with people, everybody said, where'd you get this? Can I have it? Can I put it in my white paper? Can I put it on my website? And so we also, with this, contributed this to the Linux Foundation. The V2 is going to come out next month. Again, anybody who has an appetite to participate it's in a GitHub repo. You can issue a pull request or create an issue, and there's an active team working on this. And that's all. Thank you very much.